Okay, so which one of these do you want me to go over? Okay, so you want me to do the word problems. Okay, an engineer, and on the back, he converted it to centimeters, I think. Don't worry about the conversion, and I felt bad when I saw the answer key. So, an engineer designs a small model of a cell phone tower to test the support cables. My husband is an engineer, and he has what's called demos, and he actually trains other maintenance guys and stuff on those demos, which a demo mimics the real thing, right? This is from Thursday. We're just going over Thursday's word problems. Okay, I don't think I have a Thursday this one. Yep. Well, no, you should have had two. Here's another. I think I have the other one. Here you go. We're just going over the word problems quickly. Okay. Here that the model formed by the tower, ground, and support cable has 6, 8, and 10. Okay. However, I'm going to be honest. I used ChatGPT really quickly because it was a busy week for me, and ChatGPT sucks. So it did not tell you which was which, and they actually switched them around. I believe that this was actually the tower, and this was the ground, and this is your support cable. And if you were looking at the answers and you did it from this way, which would make sense, you would have thought that 6, and then you would have gotten the wrong answer. Okay? So the real support cable is 40 meters long. That's the big one. The area of the model triangle is 24 centimeters squared. And it says first, so this is the first thing we have to do, find the scale factor from the model to the real tower. So if the support cable is 10 centimeters on the small one, but on the real tower it's 40 meters, you would do 10 over 40. Go ahead and reduce that fraction, and it should have been 1 centimeter. For each centimeter, it's 4 meters. On the back, I think it said 1 over 400, and that's because they were converting it down here to meter or to centimeters. But this, you can use this. This is what you'd actually use. So I apologize for that. Any questions? You didn't need to do the conversion. This is it's just 1 centimeter over 4 meters. From the model to the real tower. So model should be first, real tower should be on the bottom. Right? Yeah. So it should be 1 over 4. And on the back it said 1 over 400. That's because they did a conversion that they didn't need to do. This is the correct answer. Okay, just like this. So then it says, find the height of the real tower. Well, you would use the scale factor, which is 1 centimeter over 4 meters. Now, the real tower is what we're looking for, and the real tower is in meters. So your X would be down here. What is the tower height of the model? That would be 8. You would cross multiply, and you would get that it would be 32 meters. Because you would do 1 times X is X, 8 times 4 is 32, and so it'd be 32 this year. Now, when you are doing perimeter of model triangle, you would still use the same scale factor, right? I don't do anything with the scale factor for perimeter. So I would do 1 over 4 is equal to, why 4 over 1? It doesn't matter as long as you do it consistently. What is the perimeter of the model? 24. 1 is on top, 1 is the model, so 24 would go on top over x. Now, man, you could do 4 over 1 as long as you went x over 24, and you get the exact same answer, right? Okay, you cross multiply again, x would equal 96, and since it's the real triangle, that'd be meters. Now, the problem is when we start talking about area, I can't just use the scale factor as is. What do I have to do to the scale factor if I'm discussing area? You have to square it. So you do 1/4 squared, which is 1 over 16. The model area was what? It says it up here, 24 centimeters squared, but I'm going to be converting it to meters because this would be meters squared. And then you would cross, this would be centimeters squared. You would cross multiply and you would get x is equal to, what's 16 times 24? What was it? 384 meters squared. Now, if you want to see the unit cancellations, it'd be 1 centimeters squared equals 3, and then x, sorry, and 384 meters squared, centimeters squared. But then when you divide by the 1 centimeter squared, your centimeter squared cancels out, and that's why you're left with meters squared. If you are interested in unit analysis, those who are going into STEM fields in college should learn how to deal with those units. If you're not going to be an engineer, scientist, mathematician, then don't worry about it. Okay, I'm recording. Okay. A student builds a model of a bridge, truss shaped like a right triangle. The model triangle has sides 3 centimeters, 4 centimeters, and 5 centimeters. The real bridge truss has its shortest side measuring 12 meters, right? The area of the real bridge truss is 96 meters squared. Find the scale factor from the real bridge to the model. So in this case, we would put the 12 meters on top. And this was the shortest side. So what's the shortest side over here? 3 centimeters. So it would be 4. Or you could do 4 over 1 if you want. Meters to centimeters. Find the side lengths of the model. The side lengths of the model triangle were given. Yeah, those actually were given. It was 3, 4, and 5. I think this should have been the real bridge. Yeah, and if you can notice that 3 times 4 is 12, you could just multiply 4 times 4 and 5 times 4 to get the other. That's the easier. Or you could just set it up as cross multiplication. So you are correct, or you could set it up as 4m over 1 centimeter has to equal 4 centimeters and x, which you just multiply anyway. So this would be 16 meters and then 20 meters. You could set it up like this, or you can multiply each one by 4, because like man noticed, 3 times 4 was 12. Well, what's 3 times 4? Yeah, so then you could do 4 times 4, 5 times 4. Or you could set up the cross multiplication. Either way works. The perimeter of the real bridge truss is 36 meters. Find the, this is a stupid question because you could just add all these together, which would be what, 12 centimeters? 3 plus 4 plus 5? Yeah, or, yeah, that was a silly question. Now I could use 4 over 1 and then equals 36 over x if you really wanted to, and you would have got 4x equals 36, and divide by 4, x is equal to 12. That was a silly question because you could have done it either way. Why did you scoot way up there?
No, perimeter.
Yeah, because I was asking for the model triangle, so it'd be in centimeters.
Oh, that is the answer 9 cm.
9
cm. But we done with the answer is 9 cm.
What is it?
The answer is 9 cm.
9 for the perimeter?
Yeah.
Well, that's wrong. Because perimeter would be 3 plus 4 plus 5. What's 3 plus 4 plus 5? Yeah. So it's wrong on the back. I apologize. That's why I wanted to go over these. What's the area of the model triangle? Well, what's the, do we have the area of the smaller triangle?
1 4.
Oh, no. Oh, the area of the bridge truss is 16 or 96. So you do 4 over 1 squared is equal to what? 16 over 1 has to equal 96 over x. So it'd be 16x equals 96, and you divide by 16. And so what's x? What's 96 divided by 16?
6 cm. 8 and 6 cm.
6.
Is it 6 or 8?
6.
And that'd be cm squared. If you know how to calculate the area of a right triangle, it'd be 3 times 4 divided by 2, which is also 6 centimeters squared. So either way, you could get it. Okay, contractor draws a blueprint from a triangular roof gable. The blueprint has a triangle of a base of 8 inches and a height of 6 inches. The actual roof gable has a base of 20 feet. The area of the blueprint triangle is 24 inches squared. Find the scale factor from the blueprint to the actual roof. So blueprint to actual roof. So I need to put a side over a side. It says here that the base is 8 here and the base is 8 there. So it'd be 8 inches over 20 feet. But this can be reduced to what? 2 over 4? No, 2 over 5. Yes. 2 inches over 5 feet. For every 2 inches, it equals 5 feet. How you do that is you would divide both these by 4, which is 2 over 5. Right? Okay. What's the height of the actual gable, roof gable? So 2 over 5 has to equal, the height is 6 over x. So you cross multiply and you get 2x equals 30. So then x is equal to 15. And that would be feet. Find the perimeter of the blueprint the perimeter of the blueprint triangle is 26 inches. Find the perimeter of the actual roof gable. So you'd use 2/5 is equal to 26 over x. You would cross multiply. Yep. What's 26 times 5? 26 times 5 is 130. So 2x is equal to 130. What does x equal then? 65 inches. Oh, wait, not inches. 65 feet. Feet. Okay, now it says find the actual, the area of the actual roof gable. So what do we do to 2/5 before we can use it? You would square it, which is equal to 4 over 25. And then what's the area of the blueprint? 24. So this would be 24 up here, inches squared. And x is down here. So you get 4x is equal to, what's 25 times 24? 600. And then you would divide by 4, which 150 feet squared. Make sense or doesn't make sense? Terrible? Still? Is it terrible, Rosie? Should I believe him? Oh, you don't even know what problem. We're on number 13. Yeah, you guys need to be here on time. I usually start on time. I don't know about your other classes, but right when it turns to 9, I start. So if you're 15 minutes late, you just lost 15 minutes of instruction. Right, Mr. Reed? Don't I always start on time? Or I try to. Okay, let's look at these. A firefighter places a 25-foot ladder against a building. The bottom of the ladder is 7 feet away from the base of the wall. So if I have a wall, here's my wall. The ladder is leaning, so that has to be the hypotenuse. You hope that when they created this wall that it's 90 degrees to the ground. This would be your 7. This would be your 25. It's asking how high up the wall does the ladder reach. So this would be what you're looking for right here, right? So this would be like A, B, C. A, B, C, 1, 2, 3. 7 squared is equal to 25 squared. So A squared plus 49 is equal to, what's 25 times 25? 6, what is it? Yeah, 625. 625. I subtract 49 from both sides.
576.
What is it? 576? So 8a squared equals 576. You have to take the square root of both sides. So what does a equal? 24 feet. I hope the fireman that comes to save me knows how to do his geometry. Okay. An airplane is descending towards the runway. What does descending mean? No, other way. Coming down. Descending is this way. Ascending is going up. Descending is going down. When it's 5,000 feet above the ground, the pilot is 12,000 feet from the start of the runway measured along the ground. Find the straight distance from the airplane to the start of the runway. Let me reread that. Oh, measured along the ground. Okay, so here's the airplane, right? Whee, airplane. And I'm 5,000 feet above the ground. And the pilot is 12,000 feet from the start of the runway measured along the ground. So if I'm measuring along the ground, this would be 12,000 here. Find the straight line distance from the airplane to the start of the runway. Boop. So they want to know this, right? So, yep, you're finding the C, so you add the squares. And then take the square root. One, two, three, four, five, 6 zeros. 1, 2, 3, 4, 5, 6. 13,000. Maria wants to walk diagonally across a rectangular park. The park is 2,040 meters long and 1,000 meters wide. How far will Maria walk if she goes straight from one corner to the opposite corner? Okay, so here's a rectangle, right? And it says that it's 240 meters and 100 meters, and she's walking from corner to corner. And they want to know, yeah, and this is your displacement for those of you who took Miss Connie's ICP class, right? So I would do Pythagorean theorem. So again, you're looking for the hypotenuse, so you add the squares and then take the square root. So 100 squared plus 240 squared. And then I take the square root of that, 67600, which is 260 meters. So that's this answer. Shorter is this than walking around the edges. So what's 100 plus 240? If she walked this way, I'm walking. That'd be 340. And if I want to know the difference, I would subtract those two. And what do I get?
80.
So that'd be 80 meters. Okay, any other questions before I hand out the quiz?
28.
Which one? 28? Okay, for these, it's a range. So you're going to put X on the inside, and then you're going to go like this, right?
Yes.
On this side, you would subtract the 2. Make sure you put the bigger one there because you can't have a negative side line. And then over here, you would add the 2. So 8, 9, 10, 11, 3, and 19. That's it. 43. Okay. Angles, you have three options. You have acute, you have obtuse, and you have right. Acute means all three angles are less than 90 degrees. Obtuse, one angle is greater than 90 degrees. Right, one angle equals 90 degrees. So by the angles and these three definitions, which one would I use by the angles? Obtuse, because this angle here is one angle greater than 90. So I'd write the word obtuse. Now I'm going to look at the sides. There are three that we used for the sides. Scalene, isosceles, or equilateral. Scalene, no sides are equal. No sides equal. Isosceles, two sides are equal. Equilateral, three sides are equal. So how many sides are equal here? None. So it'd be scalene. So it's obtuse by the angles, scalene by the sides. Any other questions? Hello. I would sit right there and we can get you a chair, or you could sit right, because I need to be able to walk around. Okay, any other questions? We good? Yes. Okay, so I'm going to pass out the test. You are not allowed to use the review. Put that away. If I catch you using the review, then you get to start all over on a different test form. Yay! So what's this? So I'd have to take the square root, but it says here, leave in radical form. So I have to reduce this radical. The largest perfect square that goes into 128 is 64. So 64 times 2 is equal to C. When I take the square root of this, what's the square root of 64? This is 8 square root 2. Does everybody see that? So this is 8, 8, and 8 square root 2. So let's look at, I'm going to do this one. This time I'm given C though, right? So this would be A, this would be B, this would be C. So we would get A squared plus B squared equals C squared, which would be 6 squared plus B squared equals 6 square root 2 squared. What is 6 times 6? 36. Plus B squared. Now, does everybody know how to square when you have a whole number and a radical? Yes. Yeah, you would take 6 times 6, which is 36, times square root 2 times square root 2 is just 2, so multiply that by 2. So this would equal 72. And so when I subtract 36 on both sides, I get b squared is equal to 36. And what's the square root of 36? 6. Is anybody noticing a little bit of a pattern? Let's try this one. So this would be A, this would be B, this would be C, correct? So you would have 3 squared plus b squared equals 3 square root 2 squared. This would be 9 plus b squared equals 3 times 3 is 9 times 2 is 18. So then when I subtract 9 on both sides, I get b squared equals 9. And I'm going to take the square root. So b is equal to what? 3. Ha! 8. 8 square root 2. 6. 6 square root 2. 3 square root 2. Anybody noticing a pattern? What do you think this one's going to be? 2 what? 2 square root 2. Because 2 squared plus 2 squared would equal c squared. 4 plus 4 is equal to c squared. 8 equals c squared. Square root of 8 would equal 2 square root 2. Right? See a pattern? So what would this side be if I have x and 4 square root 2? That'd be 4. What would this one be? 9. So, you know how math teachers a lot of times say, show all your work. This is an exception to the rule. We want you to learn the pattern so you don't have to show your work. So this is good, especially for those standardized tests to save time. And for when we get into more complicated area formulas that you need to know these, and it makes it really, really fast. So what is the pattern do you see with 45, 45, 90? How could I write that? What is the pattern we see?
It's gonna be 45.
Okay, but what pattern with the numbers?
45.
It's over there. Oh, was there? Oh, she moved it. What do we take that side of the across from the 45s by? What do we multiply it by? To get 9, the hypotenuse, the square root of 2, right? The hypotenuse is the side across from the 45-degree angle times the square root of 2. Because I don't have a square root. I don't know the special character for that. So I just typed it out, right? Which square root of 2 means square root 2, right? So let's look without doing the math. If I have a leg.
It's done. Slowly.
Please. Did you understand the pattern? Did I go too fast with the pattern? Peter, do you understand the pattern or no? Okay, I'm going to scroll back up. Can I scroll back up?
Yes.
Do you notice that every time that I have a 45, 45, 90, that the two sides across from the 45s are the exact same number. I have 8 and I have 8. We learned that with the hinge theorem, that the angle measures are exactly the same, the opposite sides are exactly the same, right? So if this is 8, this is 8. When we do all the math, it's just 8 with what? A square root of 2. Over here, across from the 45s, are 6s. What was the hypotenuse? 6 square root 2. Over here, across from the 45s, are what? 3. So what's the hypotenuse? 3 square root 2. Do you see it now? Okay, across from the 45s here, we're 2s. So what's the hypotenuse? 2 square root 2. Across from the 45s, each of those are 4. What's the hypotenuse? 4 square root 2. Do you see the pattern? Okay, so I typed it out for you. The hypotenuse of the side across from the 45-degree angle times the square root of 2. Okay? So, here's a chart. If I have a 45, 45, 90, the two legs are going to be equal because they're both across from the 45-degree angle. So if one leg is 5, what's the other leg? And what's the hypotenuse going to be? If one leg is 6, what's the other leg going to be? So what's the hypotenuse going to be? Very good. If I know the hypotenuse is 9 square root 2, each of these would be 9s. If the hypotenuse is 14 square root 2, what would it go here? 14. Ah. Now you understand? Now this one has a different pattern to it. This one has a totally different pattern because this is 30, 60, 90. I want you to work at your tables with your calculators, figure out what the missing side length is, and then try to find the pattern. If you think you have the pattern, raise your hand, and I'll let you know if you have it correct. Okay, go ahead and work together. Use Pythagorean theorem to help you start. Okay, so who did number 3? Anybody have that answer? 10 square root 3. Across from the 30 is 10. Across from the 60 is 10 square root 3. Across from the 90 is 20. What about number 4? This would be 8. Across from the 30 is 4. Across from the 60 is 4 square root 3. Across from the 90 is 8. So, do we see a pattern here? What's going to be across from the 30 for this one? 3. Because across from the 30 will always be the smallest side. Across from the 60, you take that small side and multiply it by square root 3. Across from the 90, you just double that shortest side, so 3 times 2. So over here, across from the 30 is 9, so what's going to be this one? 9 square root 3. And when I double 9, 9 times 2 is 18. So, what's this answer, really quick? 2 square root 3. This one? 5. What about this one? 10. Because you take this across from the 30, you just double it to get the hypotenuse. 5 times 2 is 10. This one, I'm looking for across from the 30. I have 4 square root 3 and I have 8. The shorter side is going to be 4. It's either you pull it from here or you just divide 8 by 2. What's 8? What's half of 8? 4. So this is 4. Across from the 30 is 5. Across from the 90 is 10. What would this side have to be? 5 square root 3. It's actually the problem right above it, really. It's the same triangle. What would I write right here? 2 square root 3. If I were to write this pattern, why does it keep moving on me? And you will be able to use this sheet for on your test, so you can do. Okay, so let's look at this box right here. So if I know the opposite of the 30-degree angle is 4, what's going to be opposite the 60-degree angle? And then what will the hypotenuse be? 8. Because you just take 4, multiply by square root of 3, so 4 square root of 3, and then you take 4 and you multiply by 2 to get 8. What happens if across from the 30 is 1? So this would be 1 square root 3, or you could just say square root 3. That means the same thing. What about the hypotenuse? 2. It's double 1, right? What? 1 times 2. 4 times 2, right? What happens if I give you the hypotenuse is 10? Then what do? You're going to divide this by 2 to get 5. And once you have 5, now you can figure this out. What's this side? Okay, if this is 7 square root 3, what's this side over here?
7.
And then you take 7 and you times it by 2 to get 14. Over here, if I have 3 square root 3, what's the opposite of the 30? 3. And 3 times 2 is 6. Wow. You just all figured out the pattern. Now, when I write these out, when you see me, and I'm going to give you the actual lesson because there's ones that you get like whole numbers here, and then you have to figure it out. Or you get a radical here, and then you have to figure it out. But this is the way I write them also. 45, 45, 90. They call this one A, this one a, and then this one would be a square root 2. Over here, 30, 60, 90. This is another way just to describe that same pattern. Is a square root 3, 2a. So the whole idea of that exploration is to learn the patterns of 30, 60, 90 triangles and 45, 45, 90. We use that to be able to find missing sides of triangles. This only works for right triangles. We also will use this to find areas of regular polygons in the near future. So once you learn it, don't forget it because we come back to it. Okay, so I told you that sometimes they write it as a squared 2, and a squared 3, 2a. Now, what's interesting is when students write the wrong pattern on their test paper, and then they get the whole thing incorrect. Don't be one of those students. It's sad. Because I get a lot of students that will just put square root 2 here, or they put 2a here instead of square root 2. And then they get it all wrong. So make sure you understand the pattern. Okay, so a special right triangle is isosceles. So we know it's isosceles because these two angles are the same. So across from the angle measures that are the same, the sides will be the same. Both legs are always congruent. The hypotenuse is multiplied by the leg. Across from the 30, 60, 90, we did all this, but across from the 30 would be the smallest side. That's what we call A. Across from the 60 is a squared 3. Across from the 90, 2a. And we did these. Now, though, you're only given one side because we know the pattern. So here, if I know that 45, 45, 90 is a square root 2, but I'm given across from the 90, correct? Now this one's easy because I could solve by just dividing by the square root of 2. Now I'm showing you the long way because in a minute here, there's going to be some that get harder, where you get radicals and whole numbers, so you have to understand this process. So since I wasn't given across from the shortest side, I had to solve to get to the shortest side. So I just divide both sides by square root 2, right? These cancel, and I'm left with 4. You all probably looked at it and was able to write 4 right away, I would hope, because then I just wasted a good half an hour if you weren't able to do that. Okay. Now over here, this is across from the 30, 30, 60, 90. What pattern is 30, 60, 90? A, 3, and 2A. Let's say that. Across from the 30 is, everybody say A. A. Across from the 60? A square root 3. Across from the 90? 2A. Okay, we understand that? Okay, so I have across from the 30, A is 4, right? I didn't have to solve because I was given across from the smallest side. If you have the smallest side, it makes your life easy because I could just substitute in for A. So this would be 4 square root 3. This is 2 times 4, which is 8. So this would be 8 here, and this would be 4 square root 3. Any questions on that one? Okay, now it gets trickier. Oh no. Uh-oh. Okay, 30, 60, 90. You tell me the pattern. What am I going to write underneath 30? To A. Let's try that all together. A squared root 3, 2A. Okay, so now across from the 30, which is the shortest side, we know A is equal to square root 6. But now I have to substitute in for A. So square root 6 times square root 3 is what? What's 6 times 3? Square root 18. But this can be reduced. This is 9 times 2, which is 3 square root 2. So across from the 60 would be the 3 square root 2. I had to do a little bit of math for that one. Now over here, I still know A is equal to square root 6, right? So I put 2 times square root 6. So this would be 2 square root 6. Yeah, because a whole number, you would just keep it on the outside. You can't go inside the radical. The reason why these two you multiplied is they were both square roots. So, do I have one up here? Yeah. See up here, square root of A times square root of B is equal to A times square root of A times B. Right there. Second one in yellow. The one in yellow? Yeah, the roots. Yeah. Okay. So now this one's the different one. This is 45, 45, 90. Everybody tell me what goes here. Everybody say it. A square root 2. Now I'm given across from the 45, right? So I know that this is square root 2. So what's this over here? Square root 2. These two have to be the same measure. But over here, it's square root 2 times square root 2. What is the square root of 2 times the square root of 2? Square root of 4, which is just 2. Or here, the square roots cancel each other out, so it's just 2. You could just put 2 right away. We always love it when it says trickier problems, don't we? Obed does. He likes the challenge. Because why would you take geometry and not want to learn something new? Can I go to the next one? Okay. Now, this is still a 45, 45, 90, which means what? Okay, what am I given? Am I given across the 45 or am I given across from the 90? I'm given across from the 90. So that's always a sad face. The reason why it's a sad face is you have to solve whenever you are not given the shortest side, you have to solve for the shortest side. So I'm going to put right here, a square root 2 is equal to 3. But I have to solve for a. What am I going to do to both sides to get a isolated? I have to divide by the square root of 2. Now, we cannot leave. Who has learned that before? That you cannot leave a square root in the denominator. Yep. Everybody here took Algebra 2 except for you two. So you all should know, do we leave square roots in the denominator? No. We have to do what's called rationalize the denominator. We don't leave negatives usually in the denominator. We don't leave square roots in the denominator. That's a math no-no. To make this so that way we can say it is correct, that it is rationalized, we have to do something called multiplying by square root of 2 over square root of 2. This is 1. I'm not changing the value. I'm just changing the look. Okay? The value isn't changed, but the look is. So, this would be 3 square root 2 over, what is the square root of 2 times the square root of 2? 4. Square root of 4, which is 2. That is what you write for the answer right here. So we learned how to rationalize the denominator. You want to get a whole number in the denominator. You should have learned that when you did conjugates in Algebra 2. You did. Because you had Mr. Adam? Yes, yes.
Mr. Adam, you're going to teach us this.
No. Oh, I'll go ask him.
It was in the text. You said we don't have time.
Well, I just taught it to you. So now we're going to do another one. Okay, so if I have 45, 45, 90, right?
Yeah.
And this is A. This is A square root 2. I'm given across from the 90. This makes me sad. Why am I sad? You have to solve for A. So A square root 2 has to equal what? 4. What do I do to both sides? Okay, can I leave it like this? No. You have to do what's called rationalize the denominator. What's square root of 2 times square root of 2? Square root of 4, which is 2. Now, this still can be simplified because 4 can be divided by 2. You do not divide underneath the radical, just the outside. So both of these can be divided by 2, which gives you 2 square root 2 over 1, or just 2 square root 2. So both of these sides are 2 square root 2. We couldn't make it too easy on you. Oh.
Can you go back home quick? I'm almost done. Okay, I'm good now.
Okay, again, what's the 45, 45, 90 pattern? A square root 2. And we are given across from the, oh, this one's not as bad because we're given A, right? So I already know that this is 5 square root 2 over 2. I know this is 5 square root 2 over 2. But now I have to multiply, I have to substitute this in. So it'd be 5 square root 2 over 2. That is A. But I have to multiply this by square root 2. And it's square root 2 over 1, not square root 2 over square root 2. This is just square root 2 over 1. So what is 5 square root 2 times square root 2? Which is, oh, so you said 5 square root 4 over 2, but what's the square root of 4? 2. So that's 5 times 2, but I have a 2 down here. Those two can cancel. It's 5. So this is 5. Now, somebody is lucky. Who borrowed my other calculator, not those blue calculators? Who's the lucky one who has my other calculator? Okay, show that. Those do the radicals for you. It will act, if you have one of those calculators, you don't have to do all this by hand. You could actually put 4 square root 2 divided by 2, multiply it by square root of 2, and it does it for you automatically. They are wonderful. Those, Amazon. That's why when students ask me which calculator to buy, I tell them don't buy those blue ones. I tell them to buy one of those because even these calculators will not do the rationaling of the denominator or your radicals, but that one does. If you have the right tools for the job, your job's a little bit easier, right? Yep. Okay, I'm going to skip that one. I want to go to this one here. Okay, I skipped one of them because I'm looking at the time. This is 30. This is 60. This is 90. A. And 2A. And across from the 30 now is what?
3. Square root 3.
Square root 3. Well, that makes it easy because now I'm just substituting in. I don't have to solve for A because I have A. So what is the square root of 3 times the square root of 3? No. Square root of 9, which is equal to 3. And this one would be 2 square root 3. And you just write it. No, that's right. 2 square root 3. Because A is square root 3, so you just substitute it in. So this one over here is 3, and this one over here is 2 square root 3. So if you have, Rosie, do you still have that one calculator? If you take square root of 3 and multiply it by square root of 3, it'll just give you 3. If you take 2 times square root of 3, it'll just give you 2 square root of 3. I'm not going to give you independent practice. I'm just going to give you, we're going to go ahead and do these two. Tomorrow, we will do independent practice, okay? Or have the independent practice if you're not going to be here. And then, after that, we may do some fun constructions. I teach you how to balance a triangle on your finger. Gotta get some cardboard, though. Okay, so if this is 30 and this is 90, what's this one right here? 60. So I'm giving across from the 60 this time. So this really makes a sad face because I have to solve for A. So 30, 60, 90. What's the form? What's the pattern? Good job. We're getting there. Slowly. Okay, but I'm giving across from the 60. So A square root 3 has to equal 12. So not 13, 12. I don't know. I said it and I wrote down the wrong number. What do I do to solve for A? Divide by square root 3. But I can't leave it like that. So how do I rationalize the denominator? Multiply top and bottom by square root 3. This is still a 1, so I'm not changing the value. I'm just rationalizing the denominator. I am making it look a little different. So 12 times square root 3 is just 12 square root 3. What is the square root of 3 times the square root of 3? Don't say square root of 9, just tell me the answer. What's the square root of 9? 3. The square roots cancel each other out here, so it's just 3. Okay, can I leave it like this? No, because 3 can go into 12, right? So this would be 4 square root 3. So over here is 4 square root 3. Now I can substitute A in to get across from the 90. What is 2 times 4 square root 3? You only multiply the 2 outside. So what's 2 times 4? 8 square root 3. So across from the 90 is 8 square root 3. Across from the 30 is 4 square root 3. And we were given across from the 60. Last one, and then you can go your merry way. Yes. So again, 30, 60, 90. What's the pattern? A. And we're getting it. Okay, what am I given?
30.
Yeah, I'm given across from the 30, which isn't bad because I don't have to solve for A. I'm just substituting in. So since I know A is 10 square root 3, this across from the 30 is 10 square root 3 times square root 3 over 3. That'd be 10 times 3 over 3. This cancels. So that's just 10. So across from the 60 is 10. And then I need to substitute from A again into here. 2 times 10 square root 3 over 3. You just multiply the 2 and the 10. Everything else stays. So what's 2 times 10? 20. And it's 20 square root 3 over 3. And so that's how you do those. Make sure you add that to your notes. We will practice tomorrow. I think I hurt your brain enough today. Yes.
We are called.
What? I can't hear because okay, so right here it's 10 square root 3. This one? All you do it, the A is 10 square root 3 over 3. You substitute that in for A. When you multiply, you only multiply the whole numbers here. So you just multiply 2 times 10. Everything else stays. Got it? Now, the only time I would have to simplify is if this was a multiple of 3. Like if it was 21 square root 3 over 3, then I could divide. But I can't do anything, that's the answer. Got it now? Good.